I didn't do it. I love that.
What's up? No, yeah, it's just easier for them to clean, that's all. That's why I put them together. What I'm looking at doing today is going through some real basic graphing techniques with quadratics, as well as going right into factoring. Factoring is a skill that you guys tend to lack on a little bit, and it's a skill that shows up over and 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 over again. So let's talk a little bit about graphing quadratics. I know that you guys have seen this. I know that you guys have worked with this before. You did this in Algebra 1, y equals ax squared plus bx plus c.
I don't think so.
You did.
I don't remember that at all. Oh,
I remember that.
So when you're graphing, guys, got a lot to do today. When you're graphing these, this was your generic form of a quadratic equation, where you had coefficients a, b, and c. This was standard, excuse me, the standard form out of it. What you guys did, hopefully, what you first did was always found what was called the axis of symmetry. Remember, parabolas, these are all parabolas here, they're symmetrical about some axis, some vertical line. That vertical line is found by x equals something. So what you did is that you would set x equal, bless you, to the opposite of b over 2a. And that gave you that vertical line, which all these quadratics were symmetrical about. That vertical line also is where the, bless you, the value of the x-coordinate lied for the vertex. So you guys did a little bit of work with this back in the day before you had the graphing calculators, because nowadays it's a little bit easier to do some of this stuff. And as we get going with them, I'll show you some tricks. So off of this, I'm going to kind of walk you through an example. Let's just do this one. I want to look at this. I'm going to walk you through how I would graph this. Real simple, real easy. So we have y equals x squared minus 4x plus 7. The ways in which that I go about graphing these things out by hand is that I would first find my axis of symmetry, my A, O, S. There. And that's always going to be x equals the opposite of b over 2a. Well, what's my value of b in that equation?
-4.
So what's the opposite of -4?
Positive.
4. So it becomes 4 over 2 times 1. So the axis of symmetry is at x equals 2. X equals a number is always a vertical line through that number. These axis of symmetries, I always like to put them as a dotted line, because this line technically really isn't there. It is the imaginary line drawn that shows the symmetry of the curved parabola. Like I said a second ago, your vertex is always, always, always on the axis of symmetry, which means my vertex is going to be at 2 comma something. How do I find the something? It is.
It's C.
In this case, it winds up being the value of c, because it's just, well, actually,
In this
this, I'm sorry. I thought this was a 2. My bad. It's not. You have to just substitute in for x. Because here's your value of x, get your value of y. So you get 2 squared minus 4 times 2 plus 7, and that'll give you your y value. So you have 4 minus 8 plus 7 gives you 4 minus 8 plus 1.
3. Oh wait.
4
7.
minus 8 plus 7. So that's 4
Oh wait. 4
minus 8 plus 7 is 3.
Math is hard.
Yeah, for real. I was thinking.
Wow. Good morning, ladies and gentlemen.
I was thinking hella hard.
One thing to remind you, if you are using these things and you're putting things in the calculators and stuff like that, especially when we get to negative values of x and you're squaring them, you have got to make sure you put parentheses around stuff. All right, you got to put parentheses around things when you're doing that. Okay. So here, if you just typed in 2 squared, minus 4 times 2 plus 7, 3. Which means my vertex is at 2, 3. Ah, question for you. What direction does this open?
It opens.
Why? Correct. This value opens up. It opens upward because, well, it's up like a cup. Because your value of A is positive. If the value of A is positive, it's up like a cup. If it's negative, it's down like a frown.
Wait, good one.
Okay?
I missed that.
Up like a cup, down like a frown. Now, every other point
What does it
on
mean?
this parabola will have what's called a symmetric twin. As I'm looking at this, I'm going to figure out some very easy values to work with. For example, 0. If x is 0, what's y? 7.
7.
0 minus 0 is
7.
7 plus 7. So
Wait, what is
I know-
positive or negative?
Math is hard.
So I know that there is a point 0, 7, which means its symmetric twin would be at
4.
7,
Very good.
0.
4, 7, because it's 2 spots away.
Wait. Wait, 4 is 0?
I'm very good at making like the curve. I'm not good at drawing parabolas.
It's okay.
It's 4, 7.
What I'm just showing you here how you do your symmetric twins is we got the 0, 7 because 0 is very easy to substitute in. 0 is 2 spots away from the vertical axis, or from that axis of symmetry. So 2 spots on the other side is 4. That's all. When you're working with them this way, it's a very easy way of going about it. Okay. The other forms that we're going to start to show you guys are a little bit different. We have what is called, well, we had standard form. We have what's called vertex form, which is your A, H, and K. And then we have intercept form, which is our P's and Q's.
We need to know.
They're, what's that?
Will we need to know vertex form and intercept form?
Yeah, because you'll be given them in certain situations. They're all extraordinarily simple to graph out of. Very, very, very easy. Okay. You have this vertex form. I'll write it up a little bit larger on the side here. So we had standard form, which is your y equals ax squared bx plus c. Vertex form is y equals a parentheses. Notice the x minus the h again, where your h, k is the vertex. And then the intercept form is y equals a parentheses x minus p, x minus q, where p and q are your x intercepts. Bless you. Bless you.
Thank you.
They're both very, very easy to graph out of. They're very simple to understand. The axis of symmetry, well, it's just your value of h.
Okay.
See what you did there. Hi, how are you? Good. Awkward. The intercept form, when I'm talking about that, that's where it's crossing the x-axis. That's your zeros. It's very easy to plot. Okay. Obviously, they open up, open down, up like a cup, down like a frown. If A is positive, A is negative. Now, what's going to be nice is that you guys do have the calculator to help you visualize some of these things. When we get into some of this stuff, though, a lot of times what I do is I will do calculator, non-calculator portions of tests and quizzes, because that's how I roll. All right. So you guys have to understand, how do you come up with it? Because when you take the ACTs and stuff like that, you're going to see some of these things. And when I ask you what's the axis of symmetry of this, this, and this, you can figure it out real fast instead of having to use your calculator, because you know, oh, it's just the opposite of b over 2a. So, let me show you an example of vertex form.
Let's go vertex form.
This is an example of vertex form. We have y equals 2 times the quantity x plus 1 quantity squared minus 4.
What is the goal for this?
what we do here is we're first going to find our vertex. So my h value in the parentheses is at a positive 1, which means what's my h when I pull it out for my vertex? Negative 1. This is going to be opposite. Whenever you see this x minus something, your value is going to be opposite of what you think. So your vertex is at negative 1, oops, and negative 4.
Is it only the H that's?
Yes.
Is this-
Yeah, and you'll see that because it has the opposite h here.
So it's like we graphed absolute values.
Very similar.
Okay.
Yeah, very similar. That's why I wanted to show you guys that absolute value one, because that's the intro of A, H, and K in a very easy situation.
All right.
Sorry, aren't you squared?
So if my vertex is at negative 1, negative 4, where's my axis of symmetry? What is it? It's at negative 1. Because what's the x coordinate? Negative 1. So my axis of symmetry is at x equals negative 1. It's always that value. Always. So I know that there's this imaginary, oops,
How do we know?
symmetry right there. What's that?
Hold on.
Remember, your vertex always lies on the axis of symmetry. Your axis of symmetry is always the x-coordinate of your vertex. Always, always, always. Now, sometimes finding the extra points out of intercept form can be a little bit tricky because you just got to be careful with your values. But what's a nice, easy number that's really close to my axis of symmetry that I can use?
0.
0. So if I use 0 for x, and I go 2, parentheses, 0 plus 1, quantity squared, minus 4, you get negative 2. Because this is 1 squared is 1, 1 times 2 is 2, 2 minus 4 is negative 2. Which means at negative 2, it's also here. Okay? You get a rough idea of where it's going, how narrow or how wide they're opening. For the time being, we get a curve. And we knew it's up like a cup because the value of 2 is positive. Sir,
How'd you get 0?
I just picked a number.
Okay.
All I'm doing is picking anything that's easy to work with. I could have picked 12 if I wanted to. But what I'm saying is since 0 is always an easy number to substitute in for, just pick that. I could have picked 1.
So H is like X, right?
Yep.
Okay.
And then the same idea goes for when you're working with what's called intercept form. Intercept form is you're going to plot the zeros. And that came from factoring. And you'll start to see a little bit more of the factor when we do some of those examples here in a little bit. When you guys did this, let me see if I can remember off the top of my head here. When you saw a problem like that and you were asked to factor it, do you remember what you did? Multiply to the tail, add to the middle. What times what's 15? You add together, you get 8. What is it?
5 and 3.
5 and 3. So you would factor this as x plus 5, x plus 3. Did it matter which order it went in? No, it had no bearing on it at all. What changed when it came to that? Then you solve. You were solving for your zeros. What would be the zeros then of that? It would be at -5 and -3. What you guys were doing back in the day when you were solving for the zeros on that is, in essence, you were finding the intercepts. You were figuring out where the parabolas crossed the x-axis. You knew that at -5 and -3 you had zeros, because that's what this means. You also then have 2 points that are symmetrically apart from one another, from some imaginary vertical line. What's halfway between -5 and -3?
-4.
Where do you think the axis of symmetry is?
-4.
Probably at -4.
Maybe.
But where?
The axis of symmetry winds up at -4, which means what is the x-coordinate of my vertex? negative 4.
How'd you get
Why is that?
Axis
Remember,
with the axis.
your axis of symmetry,
Is always
when
the
you're
x
in-
value of the vertex.
intercept form is the midpoint of the zeros.
It doesn't matter where you put the axis of symmetry. Vertex side right over here.
Is it E, O? What was it?
That's
No,
not
it's
right.
zero.
It's just, oh,
Why did I think there was another E there?
You're,
That's
you can't
crazy.
spell.
Yes. So your axis of symmetry is always going to be at the midpoint of your zeros.
What does that mean? AOS?
What do you mean?
Like, is that the midpoint of your zeros? Like,
Negative 5, negative 3 are your zeros,
those are my zeros?
where it crosses the axis.
Oh, okay, I know what you're saying now.
And that's the midpoint. The midpoint is just the axis of symmetry is halfway between them. So it's at x equals 4, negative 4, which means the x coordinate of my vertex is negative 4. What do you think I have to do with that negative 4 to figure out the y coordinate?
Fill it in.
Substitute in.
Okay.
So if I go back in, and remember, this is a good example of when to use parentheses. Parentheses, negative 4 squared. Is it plus 8 parentheses negative 4 plus 15? And I type it in literally exactly the way that I'm writing it down.
Are you? Oh, never mind.
And I hit enter. And there's my vertex. Negative 4 and negative 1. Plotting out of any of these,
Was it a negative one?
yes. Did I say positive 1? I meant-
No, no.
Yes, it was negative 1.
Okay. It was like the first equation. It says that.
So all I'm doing is taking that x value, that midpoint, that tells me my axis of symmetry, that tells me my x coordinate of my vertex. I just substitute back into the original equation, and boom, there's your y value. They're very, very easy to work with. Obviously, it's up like a cup because the vertex is below them. If the vertex was above them, it would be like a frown. So let me show you the official way that they write this out. The official way would be y equals a
Yeah.
where this value of a outside is the one where it's positive or negative, tell you if it's up or down. So if you're looking at it, a lot of times I went through a couple extra steps with you guys to show you how the factoring got you to the zeros. What they're going to do today is just give you the terms themselves and you'll build out of it. Fairly simple. Let me show you another example. Where was it? I got ahead of myself here. Here's an example they'll ask you to graph. You notice all I'm graphing here is I'm putting my axis of symmetry in it, and I'm finding the vertex, and I'm usually just finding one set of points. When you have something already in intercept form, you're going to be able to find that one set of points a lot quicker. So really all you have to find is your vertex and your axis of symmetry. One thing I know for certain is that I know what direction this is going to be opening. Which way is it going to be opening?
Down.
It's going to be down like a frown, because it's negative. So if I'm looking at this, I have x plus 2, x minus 1. What are my two zeros?
2, negative 2, and 1.
1 and negative 2, very good. It's always the opposites. 1, negative 2. What's halfway between 1 and negative 2? Negative half, very good. So you have an axis of symmetry, an AOS, at x equals negative 1/2. And now since you have it written in intercept form, when you go to substitute that back in your calculator, do you guys all know how to put the fraction in the calculator?
yeah.
Alpha y equals? Or in this case, since it's an easy number, I'm just going to do 0.5. It's quicker to type in, usually. So I have a negative parentheses, negative 0.5 minus, oh, I'm sorry, plus 2. And then negative 0.5 minus 1. 2 1/4. So my vertex will be at negative 1/2, positive 2 1/4. And then obviously if I'm typing this into my, or putting this in my graph, I put up 2 and I just kind of, but I'm labeling it. And I know it's falling down. That's really all you have to do. Graphing is easy. Very, very easy. Okay? Factoring, on the other hand, is what you guys tend to struggle a little bit with. And there's a silly reason why you guys struggle with it. You don't know your times tables.
I do not.
Clear your desks.
Wait.
You can't do this to me. You can't.
No, you have to just put yourself on the floor.
I would be I want to change them.
I memorized them.
I
know all the way through 12.
I'm going to steal your desk.
What's the point? B plus minus
Do not start this.
No, don't make me do this. I can't.
Leave it face down. No calculators.
Are you sure?
Yes.
We just do time?
Yeah.
Alright, I'll do 10, 1, 16. For the grade, please.
The idea here.
Zeros and the ones, guys. Sorry, I was supposed to show you. Yeah, those.
So here's the deal.
And the ones you die. Sometimes I'll just use my fingers. Can I get started? Like,
No.
No. Sassy. Sassy boy.
Ah! Ah! No flipping over yet.
Well, it's pretty like what? Like,
On your marks.
we were like.
Whoa, 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 whoa!
We're
We're going. Get set. Ah, no! I didn't say go yet. Whoa, whoa, whoa! Flip them back. I didn't say go. Go!
I can do zeros.
I know, right?
I can't break my those are zeros.
I can do zeros.
I think so.
I know.
Love it.
I know.
Love it. Take that.
Take that.
Anyway, like I'm saying, the idea here is that you need to know your time span. I'm done with it. You guys can finish this at your
You gotta
leisure.
finish this.
Because I'm going to continue.
No, you gotta get quiet.
I'm getting places. 9.
You guys can finish this later. Seriously,
not
that's, well, I'm saying you can finish it later because I'm continuing. Okay.
Look how far I made it.
Take something out. Put it away, guys. You put it away. You can finish this later. Okay.
Don't be mean. You made us do this
close.
thing.
The whole idea.
Just ruined our lives.
The whole idea.
Got the little box.
I got this one. Wait, why are you guys? Yeah, we all. Look at that. I was going like.
The whole idea here is being able to know your facts quickly.
That's not my problem.
I got
The multiplying and the adding.
You guys like
The 12.
Adding's another.
No, you go. I do.
Write this down.
I'll finish this later.
When I'm factoring, I factor things a little bit differently than other people have. I go back to the way that I was taught. I fall back on the most basic way of doing it because it always works. There's no fancy box method. There's no guess and check. There is a process and a process that's followed, and if the process is followed correctly, you get it correct. I know that there are so many other ways of going out there and doing this, but I always fall back on the what multiplies to the tail adds to the middle. What times what's negative 28, but you add it up, you get negative 12. When I see that, I have two negative values. That means I'm going to have two terms. One's positive, one's negative. The one that's negative will be the bigger of the two. Have the larger absolute value, I should say. Therefore, you get the negative middle term. So I'm just looking, well, what times what's negative 28? Well, my factors of 28, I've got 1, 28, 2, 14, 3 doesn't work, 4 and 7. Trying to figure out which one of those mixed together will get me to negative 12.
Wait, why are you using negative 12 then?
Because that's what the numbers are.
It's negative 14 times positive 2.
Okay.
X minus 14, X plus 2.
Oh. Just
That's what I'm saying.
gave that one away.
Oh, no.
What I'm looking at here, guys, is quick math. Shouldn't need a calculator.
Wait, we're working.
Absolutely, means the same thing.
Alright.
Okay? It does not matter which one goes first. As long as your signs are correct, you're always going to be right. Because you'd FOIL that out and you could check it and it's no big deal. The idea here is that you can group these together to set them up. And the quicker you are at it, the faster you can do some of these things in your head. That's why I harass you guys every year with this little times table test, which I'm still undefeated in.
I'll come back next year. I'll be ready. Alright? I'll take
Really?
your shot, buddy.
That's pretty close. That was probably about the closest anybody's ever been.
What was he at?
He was halfway through his 12s.
Oh, sorry.
I was not doing any of my 12.
Just do this mentally.
Me neither.
What times what's negative 21 you add together get 4?
7 and 3.
Which one's positive, which one's negative?
Either one.
I'll be thinking that right
Good.
quick. I had to think this.
Now, let me ask you this then. What changes if it asks you that?
I don't know. They did it
X equals negative 7 and X equals 3.
Perfect.
How'd you guys?
What they're doing here, they're saying what are the zeros? The zero's at negative 7 and 3. Where does it cross the x-axis? Negative 7,
I
3.
feel like 7, 3.
Okay? That's the whole idea here. It's can you go through quickly and multiply them out?
I cannot do that.
How'd you just like know?
Positive 28 to negative 11.
Like I can't do that.
Very good.
No.
Notice this one here, you've got two numbers you have to multiply to get a positive, but you're adding for a negative, which means they're both negative. Okay? The process of the one that you guys don't like is the one that has a leading term coefficient that is not equal to 1. Okay? I still do the same method, believe it or not. It just looks, it's actually just one step further if you want to think of it that way. Where is it? Here we go.
Oh.
3x squared minus 17x plus 10. I still multiply the tails together. What multiplies the tails? Because think back to what we just did a second ago. We had what? X squared minus 11x plus 28. We said what times what was 28 to add together to get negative 11. But what's the coefficient of the x squared that you just don't see? 1. So what I'm doing is I'm multiplying my ends together to add to the middle. I'm doing that process, but it's just quicker because it's a 1 out front. Here's what happens now. What's 3 times 10?
30.
So what I'm looking for is what times what's 30, but it gets to me to a negative 17. Yes, sir? Negative 15, negative 2, very good. So here's what I do. I know it's going to be negative 15.
Why does this still add up to like 17? But like then you like times the 3 by the 10.
That's the process. You multiply the ends, add to the middle. So what I'm doing here is I'm splitting this middle term. You'll hear people say it a couple of different ways. Split middle term or factoring by grouping, however you want to put it, it all means kind of the same idea. So what I do is I'm going to rewrite this as 4 terms as opposed to 3. And now I take GCFs twice. Okay. I group this first one like that. And what's the GCF of 3x squared and 15x?
3x.
3x. So I factor out the 3x, and I'm left with x minus 5. The second group, I want to do the same thing. I want to get a GCF. But I want you to pay attention to what happened here. Notice my third term is negative. Whenever you wind up with the third term negative, you want to, when you group it, I always say to do this so that way you remember to take the negative out. Because you want that second parenthesis to be exactly the same as the first one you made. Watch. What's the GCF of 2 and 10? 2. So if I take out a negative 2, negative 2x divided by 2 is positive x. Positive 10 divided by negative 2 is negative 5. It's reminding me by throwing that negative in there to remember to factor it back out. So are those 2 terms in parentheses the same?
Yes.
If those 2 wind up being the same, which they should, you just write it down. And what's left? 3x minus 2. It's an extra step than some methods that people show. I know people have done that guess and check. There's all these different ways you can go about doing this. I like this method because it will always work. It's something that you can fall back on, and it'll always work. Okay?
No.
I did forget to ask you guys though, what is the very first rule of factoring? GCF. Don't kill puppies into GCF. You always want to see if you have a GCF before you do anything. Okay?
Cool.
You'll find out that the book always tends to change variables on you. I don't know why. It just does. 9.5 times out of 10, I'll just wind up rewriting it with an X as I start doing it. So if you see the variable automatically change, it's not your eyesight, it's just me. Okay. Now, this is where things get interesting because there are also all of these different special patterns that happen. If you recall, let's see, which one was it? Let's look at that one first before we do the one with the coefficient of 9. What can you tell me about the relationship of those values? Of the x squared, 18x, and an 81? Besides the fact that they're flip-flop. That's just dumb luck. Okay.
They're both divisible by 9.
Okay, they're both divisible by 9. Now, if you go through the long way, you'd ask what times what's 81 to get you 18, right?
9.
9 and 9. So this is junk
Let's jump.
squared. First term's a perfect square, right? X squared is perfect square.
Yeah.
Is 81 a perfect square?
Yeah.
What's the square root of 81?
9.
Double it.
18.
Isn't that the middle?
Yeah.
It is.
That is this is a special pattern. This is a perfect square trinomial. Okay? Perfect square trinomials have these fancy patterns that happen. If you have this ax squared bx c. Oh, I don't want to write it this way. Basically, let me rephrase this. Is this term a perfect square?
Yes.
9y squared. What's the square root of 9y squared? 3y. Okay. Is 16 a perfect square? What's the square root?
4.
What's 3 times 4? 3 times 4. Double it.
I see.
Perfect square trinomial.
I think I got it.
As he picked up his hammer and saw.
I did it the hard way.
And that's fine. All I'm saying
Got
here,
it.
there's absolutely nothing wrong with going the long form and multiplying out. You get the same answer.
I think so.
Well, I'm gonna have to.
What happens here is that you pick up on some of these shortcut patterns that occur. This was a perfect square. This is a perfect square. These are both plus signs. 3 times 4 is 12. Double it, and all of a sudden you get
24. I'm so
done.
So is 24 the answer?
No. Your answer is 3y plus 4 quantity squared. That's what that would look
I'm not
like.
going to pick up on it.
I don't understand this.
Oh, that's what I got.
Oh, yeah.
That's fine.
It was just C plus 4, and then I put it forward.
Yeah, that's fine. Yes,
See how we
sir.
got the 4, but
Like,
see how we
we
got
set it equal to 0, then we'll do it.
Ah, great. If you set this equal to 0, that means your solution would be just negative 4/3. You'd only have 1 0 here because it only touches the x-axis at one spot. Okay? Since you have that same term repeated, you only get 1 0 out of it.
Well, I'll go with the long way.
Wait, that's only if it just touches the X.
How would you do that for the long?
Should have started
9
with
times
that
16.
now.
What times what's 144 that adds together to get 24?
Yeah, I know.
And it's a long way of going through it.
I know.
That's why we do these shortcuts if you can do it.
But I can't do it.
Yeah, I can't do it. I don't know how we did the first one. I got
Let's try another one.
mistakes.
Very helpful, mister.
Wait, I wasn't done with the other one.
I know, exactly. Are we supposed to understand?
4x squared minus 9.
Are we supposed to, what are we supposed to do with this? Like, are we supposed to like put it
Hold
in,
on.
it's like
Something
longer?
with the
In
four.
this case,
Be 1 y.
there's no middle term. There's no x term. There's no b value. So when you see patterns like this, you ask yourself the following questions. Is the first term a perfect square?
Yes.
Yeah.
Is the last term a perfect square?
Yes.
Is that a subtraction symbol?
Yes.
If you answered yes to all 3 of those, your solution is
1.
Why do you minus m plus 3? I don't
Oh,
get
I
that.
knew that.
And I did this differently because you were probably waiting to see something like this, x squared minus 25.
What?
That's called a difference of squares. First term's a perfect square, last term's a perfect square, subtraction in the middle. Every single time if those 3 things are true, it's going to be plus minus the square roots of the tails. Always, always, always. What times what's negative 25? You add together to get 0. 5 and negative 5. It's the same idea. Okay, it's the exact same idea. We just don't put the 0 in there. It's just a shortcut difference of squares. That's what that looks like. I know you've seen this. It's just a little bit of a refresher.
I know.
I've seen the other stuff, not this.
We have to go back.
Quick short.
This little
Jump on
shortcut
it.
thing, it's not anything. Whenever the value missing, I'll just have to remember.
Okay.
Oh, I don't like this.
Going along the same lines. 49r squared minus 14r plus 1.
Oh, negative 737.
Notice that it's going to have to be two negatives because it goes negative positive. So you can multiply out what times what's positive 49, you have to get negative 14, or is that first term a perfect square? Is 1 a perfect square?
No, it's not.
What's the square root of 49?
7.
7.
7r minus 1.
Bless you. If you go long form, it still works. It'll still work. Let me give you guys a few of these things to go.
Do that.
Oh, I tried dividing by 2. That's why.
I want you guys to try a couple graphs and a couple factoring. We'll see going out of it.
I understand it, but I don't know why it works.
Take roots 2.
Good enough for me.
Yes, and I took 2, A, B, and then some variables.
The same thing you spoke like.
B is international food kind of, and then A is like.
But how do you get graded in that class? Like, you know how like food is taking food?
It's just a test for that.
How do you like get tested though? Like, oh, like knowledge. Like, oh, cool. Like that's what utensils like.
Yeah. I gave you 3 graphs, one of each.
Oh, this is so much. Oh, like that. I like utensil that can be like.
Okay. In your book,
Oh.
in your book, you'll see that there's. I'm trying to do 20. I'm trying to do this by 3s here. I'm trying to give you a couple of them to work through.
Is this homework? Yeah, yeah.
What else have you seen?
Does that make sense by 3? So we can have you do every third. 24, 27, 30, 33, 36, 39.
Write those
I'll
out.
probably
Yeah.
just buddy.
That's what that means.
Oh.
Okay. And then we'll worry about the funky equation stuff. We'll do that tomorrow. Okay?
I'd be so confused on looking at this later.
Factor, factor, factor. We'll build out of this. Okay?
Wait, Mr. Murphy, can you come here? I'll just show him that line.
Hey, can I have my bar?
Best to accept, not to understand.
What's that?